In the previous videos, we saw some examples on constructing DFAs. From now on, we will be constructing minimal DFAs for a given language. So what is minimal DFA? A minimal DFA is a DFA that accepts the language and has least number of states. For any regular language, there can be multiple DFAs which accept the language, but there can be only one minimal DFA. So a minimal DFA is unique and has minimum number of states. Let's try to construct the minimal DFA that accepts all strings of A's and B's including epsilon. So given alphabet is A comma B and the language is set of all strings over A's and B's including epsilon. So epsilon A, B, AA, AB, BA, BB, BBA, AAA and so on. All the combinations of A's and B's including epsilon are in this language. If you observe this carefully, this language is nothing but sigma star, which is our universal language or Kleen closure. So let's try to draw a DFA that accepts all strings of A's and B's including epsilon. Since we have epsilon in this language, the initial state should be the final state. So let's say P is my initial state and it is one of the final states in our DFA because we have epsilon in our language. On seeing symbol A from initial state P, we go to another state. Let's say this is Q. We need to accept this string, so Q is our one of the final states. Let's consider string B. On seeing symbol B from state P, we go to other state and accept it. So B is accepted. If we consider string AA or AB, we get the transitions over Q. Now let's see that. On seeing symbol A from state P, we go to state Q. From state Q, on seeing symbol A, we need to accept this string. So we will be in this state. Let's consider the string AB. On seeing symbol A from state P, we go to state Q, and on seeing symbol B from state Q, we need to accept this string because this is in our language. So on seeing B from state Q, we will be in this state only. Now see if all states are complete. By complete, I mean check whether all states have transitions over all the input symbols. So we have symbols like A and B. So P has input symbol, transition over symbol A, transition over symbol B. So P is complete. For state Q, we have transition over A and transition over B. So Q is also complete. So this is our DFA for sigma star, our universal language. Is this the minimal DFA? No, because we can have a DFA with less than 2 states. We have 2 states here. And we can have a DFA with less than 2 states which is accepting the language sigma star. Let's try to draw that DFA, which is our minimal DFA. Since epsilon is in our language, the initial state will be our final state. Let's say P is our initial state and final state because of epsilon. On seeing symbol A from state P, we can accept this string and we can be in this state only. Unlike this example, this DFA, we are going from state P to state Q on seeing A, but we can be in this state itself and accept this string. Similarly, on seeing B, we stay in this state only without going to any other state like we did in the earlier DFA. So accept B. If we see any combination of A's and B's, we will be still in state P and accept that string. So this is our minimal DFA for sigma star, which is our universal language. Since this has only one state, this is regarded as minimal DFA. Let's try to construct a minimal DFA that accepts all strings over A's and B's and excluding epsilon. Let's construct a DFA and a minimal DFA for this and see how it looks. So the alphabet is A, B, and the language is excluding epsilon. So the language will have set of strings over A's and B's excluding epsilon. BA, BB, AAA, AAB, and so on. So if you see, this is sigma plus, which is our positive closure. We need to construct a DFA, a minimal DFA for accepting the language sigma plus. Since this language doesn't have epsilon, we can say that initial state is not a final state. Let's say this is P. On seeing symbol A from state P, we go to some other state where we accept the string. And if we consider string B from state P, on seeing B, it goes to Q, which is our final state, and accept this string. If we have string AA, we reached Q on seeing A, and from there if we see an A, we need to accept this string. So this will be going to state Q itself. If we consider string AB, we reached state Q on seeing A and we accept the string on seeing B. So we will be in this state itself on seeing B. Now both the state P and state Q are complete. By complete I mean state P has a transition over each input alphabet A and B, and Q is also having transition over each input symbol A and B. So this is our DFA for sigma plus, which is our positive closure. Is this the minimal DFA? So here we have two states. Is there any way to reduce the number of states less than 2? Since we don't have epsilon in this language, we can't have the initial state as final state. We need to have this transition on seeing any symbol A or B. So there is no way to reduce the number of states from 2. So this is our minimal DFA for sigma star, which is our positive closure.